So here we have the stock's ISOBUS option with a demonstration screen. We've seen an increasing amount of ISOBUS options going out with particularly our turbojets, but also going through with our drill OEM partners, with our applicators being fitted as a secondary unit to the seed drill. If you buy one directly from us, there will be a setup manual, should be included in the box. If not, it is available from the operator's manual section from our website, and there are some critical setup parameters that we need to do to make a stock applicator work with ISOBUS. First of all, within the junction box itself there are some micro switches which dictate the channel that the stocks applicator will work on through ISOBUS, and that is all quite clearly described in the manual. First of all, before we do anything, you may plug it in and you may get a module offline. That is because you do not have the correct micro switch position in the junction box, and this should be adhered to from should be both up, and when you turn it on you should get this screen in front of us, and you shouldn't have any module offline. If you do, please reread the instructions. On the setup, we use the scrolling arrows. There's a lot of this that's very similar to the icon. It's just some of the buttons are in slightly different places. So we scroll through to factory settings. The factory unlock code is in the manual, is also 1234. So on the channel setup, we just need to make sure we've got the seed. This is here where you'd select the working width for your implement and check that it's ticked and in use. And the module setup we use is APM module, which is applicator module. And then in the metering setup, this is where you have to follow the instructions very clearly to get these ratios correct, otherwise the machine will not work properly. So you check that the shaft 1 and shaft 2 are set to 0 pulses per revolution, prime switch to latch in, gearbox ratio important 50:1, the encoder is 12 pulses a revolution, and then you have the minimum motor speed of 3000, maximum motor speed of 3000, minimum to 0. Change the max current for the motor to 10 amps, and then these underneath don't need changing, and this is all dependent on what channel we're working on. So on this machine we're on channel 1. If you were working on a seed drill, you might find the drill was using 1 for seed, 2 for fert, and the stocks machine might be on 3 or even 4. And then after metering unit setup, we have APM module setup, applicator module, and this is where you dictate what model it is. So here we have a digital fan, which would represent a turbojet. From here we have a gravity fed machine, which would be a rotometer, a fan machine, which would be like the rotorjet, or the spinner machine, which would be FanJet Mini or a Pro Plus. In this instance we're working on digital fan, so turbojet. In the TL module setup, we have to change these fan alarms to 0 because we're measuring current for the fan alarm, not the pulses per revolution like on a hydraulic fan. The module we're using is a combi bridge, and then that should be the basic setups done for your machine to work. And within the drill setting here we have the combi bridge for the cutout source. That can also be selected to be ISOBUS, or if we were using the standard cutout switch source plugged into the side, the finger switch, you would select MCM APM. On here, on the main screen at the front, if you're on this screen here, to make any adjustments you have to have a row of crosses, and these crosses dictate that the machine is out of work. The alternative to that is here, the cutout source. To reverse the way the cutout source works, you can reverse 5 to 0 volts, and you can see here now they are a row of ears of wheat. So if the machine is in work, you should see the ears of wheat. If the machine is raised and you see those, you need to reverse it. Or occasionally, if the machine is on the ground and you want it to make some adjustments, you can change this setting again, which is in drill setting, cutout source, and then reverse the signal. Within here you can set the application rate, so this is set at 15 kilos a hectare. You have the cal factor here, which is 115 grams a revolution, and then for the calibration you can either run the calibration, input a weight and have it weigh out. Personally, I prefer the manual calibration. Press the prime button on the junction box, the machine will start metering out product through the hatch in the bottom to catch and weigh the product, and use a set of scales to 3 decimal places. So when you've got enough to weigh, you'll stop the machine, and then what we do is the machine thinks it's weighed 550 grams, we weigh it, we've weighed 570 grams, so we enter 570 into here, and then OK, and our cal factor has now changed. We've gone from 115 grams a revolution to 120. We've now got a maximum forward speed of 25 kilometers an hour. The ISOBUS option does not give you a minimum speed. The icon does, the ISOBUS doesn't. Again, like you would do with the icon, you would repeat that calibration until what you've weighed is within a few grams of what the screen says. When you're working, you have a nudge factor where we can nudge the rate up and nudge it down again, or press the target to revert back to how we set it. And then the simulated speed setting on this is within the drill setting. At the top of the forward speed you can sit in here. So at the moment the speed source is from the GPS and ISOBUS, or we can come from the combi bridge. So if you're running full ISOBUS, it should be on GPS and ISOBUS. We can turn simulated speed on and off at clicking that tick there. That can be used for static testing, or if for any reason you can't input a speed signal, and you can change the simulated speed there. The alarms page is set where you have motor inhibited, but all these fan speeds are turned off because we're measuring current, not RPM.